We are asked to find the values of sine of theta and cosine of theta for theta is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And I assume that they're talking about these angle measures being in radians. So let's figure out what this is going to be. And to do that, let's set up ourselves with a little bit of a unit circle. We'll use the unit circle definitions of our trig functions, especially because I suspect many of these are going to not be able to be done purely with SOHCAHTOA. They're going to be beyond 90 degrees or beyond. So let's figure out. So there's our unit circle. And also just to kind of visualize these a little bit better, or maybe use our knowledge of some triangles where we know the angle measures in degrees, let's convert these radian measures to degree measures. So if we have pi over 3 radians, so pi over 3 radians is going to be equal to, well, we know how many degrees are there. How many degrees are there per radian? Well, for every 180 degrees, you have pi radians, so there's 180 over pi degrees per radian. And we see the pi's cancel out, and you are left with 180 over 3, which is 60. The radians cancel out, as they should, 60 degrees. And we can just write it just like that. So pi over 3 radians, this one right over here, is 60 degrees. This one over here, this is 2 times pi over 3. So if this was 60 degrees, well, this is going to be 2 times that, so it's going to be 120 degrees. But if you want to verify it, you could have 2 pi over 3 radians times 180, I'll write it like that, 180 degrees for every pi radians, and you are left with 2/3 times 180 degrees, which is 120 degrees. So this is 120 degrees. Now, you can see that 4 pi over 3 is just double of what 2 pi over 3 is. So 4 pi over 3, you can immediately say, is going to be 240 degrees, but you could work it out as well. 4 pi over 3 radians times 180 degrees for every pi radians comes to, the pi's cancel out, 4/3 times 180 is 240 degrees. Now, by the same logic, what's 5 pi over 3 going to be? 5 pi over 3 radians going to be in degrees. Well, there's several ways you could think about it. This is literally 5 times pi over 3. Pi over 3 radians was 60 degrees, so it's going to be 5 times that, so it's going to be 300 degrees. Or you could just work it out. You have 5 pi over 3 radians times 180 degrees for every pi radians. This quantity is literally equal to 1. That's why you can just multiply this quantity by it and not fundamentally change the value. It's just how you express it in terms of units. And you're left with radians canceling out, the pi canceling out. And you have 5 times 180 over 3, which is 5 times 60, which is equal to 300 degrees. So we've done the first part, which is really just put them in degrees, which at least in my brain is a little bit easier to visualize. And now let's actually try to draw these angles in degrees and then use a unit circle definition and maybe our knowledge of certain types of triangles to figure out what the sine of these angles are and the cosine of these angles. So first, let's draw a 60 degree. Let's draw a 60 degree angle. So 60 degrees is about 2/3. It's exactly 2/3 of the way. So it's about like that. So a 60 degree angle would look like that. So that right over there is our 60 degree angle. And remember, the sine of theta and the cosine of theta are really the y and the x coordinates of this. So this coordinate right over here, that point is literally going to be, by the unit circle definition, the x value is going to be cosine of 60 degrees, and the y value is going to be sine of 60 degrees. So how can we figure out what those x and y coordinates are? So the cosine of the angle is going to be the x coordinate, and the sine of the angle is going to be the y coordinate. Well, let's just draw a right triangle here. So I'm going to try my best to draw a right triangle. So now we have a 90 degree angle, we have a 60 degree angle. We know that since all the angles in the triangle have to add up to 180, that this has to be, right, this has to be 30 degrees. And we are left with a 30, 60, 90 triangle. And I will do a little bit of a review of a 30, 60, 90 triangle. If we have a triangle, let's say we have an equilateral triangle that looks something like this. If we have an equilateral triangle, that's an equilateral triangle, all the sides are equal. Let's say all the sides have length 1. All the sides have length 1. We know that all the angles are going to be the same, and they're all going to be 60 degrees. They're all going to be 60 degrees. Now, what if we were to just split this top angle right over here and drop an altitude just like that? We know this is a symmetric triangle, that this angle right over here, is we split that angle, it's going to be 30 degrees. 30 degrees. And we know that we split that opposite side right over here. That's going to have length 1/2. And if you use the Pythagorean theorem, if you have a triangle where, let me set it up. Let me set up a little bit. If you have a triangle like this, so hopefully I've convinced you a little bit. It's not a formal geometric proof. We do that other places. But I've convinced you that if you have a side length 1 here, you have 60 degrees here, and you have 30 degrees here, that this length right over here is going to be 1/2. Now, if you use the Pythagorean theorem, what do you get for the other length right over here? Well, you get square root of 3 times this length, which is square root of 3 over 2. So this is everything we need to know. This is everything we need to know about 30, 60, 90 triangles, which this is one of them. So how can we figure out the dimensions of this? Well, what's the length of the hypotenuse of this 30, 60, 90 triangle? Well, this is a unit circle. That means it has a radius of 1. So that means that this length from here to here has length 1. So given that information, what is this length down here? Well, it's a 30, 60, 90 triangle. The side opposite the 30-degree side, or the shortest side, is going to have length 1/2, just like we saw there. And what's going to be the length of this side right over here, this long side, the side opposite the 60-degree side? Well, 30, 60, 90 triangle is going to be square root of 3 times the shortest side, so it's square root of 3 over 2. So let's go back to the question. What is cosine of the 60 degrees going to be? Well, that's the x-coordinate. That's the x-coordinate of this point, which is this value right over here, which we see it is 1/2 in the positive direction. So this is going to be, let me write this down. So cosine of pi over 3, which is equal to cosine of 60 degrees, is equal to 1/2. Now let's do sine of pi over 3. Sine of pi over 3, which is equal to sine of 60 degrees, is equal to, what's the y-coordinate? The y-coordinate is this height. It's square root of 3 over 2 in the positive direction. This is square root of 3 over 2. Square root of 3 over 2. So this is equal to square root of 3 over 2. Now let's do the next few. So we need to figure out 120 degrees. So 120 degrees, so this gets us to 90. We're going to go another 30 degrees. So it looks something like this. It looks something like that. That's my best attempt to draw a radius. So this right over here is 120 degrees. Now, how can I figure out the x and the y coordinates of that point right over there? Well, I'll draw another right triangle. I'll draw another right triangle. So here we go. That's 90 degrees. And what's this angle going to be right over here? What's this angle? We do this in a neutral color. What's this angle going to be? Sometimes called the reference angle. Well, if we go 180 degrees all the way to get to that point, this white angle is going to be supplementary to it. They're going to add up to 180, because if you add them together, you go halfway around the circle. So this is going to have to be a 60-degree angle again. 60 plus 120 is 180. So now again, we have a 30, 60, 90 triangle. 60, 90, and 30. So what are going to be the lengths of the sides? First, we already know the length of the hypotenuse is 1. This is just another radius of a unit circle. What is going to be the length of this side? Well, it's the side opposite the 60 degrees. So it's going to be square root of 3 over 2. If we just talk about the length of that side, I'm not talking about the direction just yet. And then what is going to be the length of this side, the base, or the side that's opposite the 30-degree side? Well, that length is going to be 1/2. So based on that, what are the x and y coordinates over here? And we know that the x coordinate is the same thing as the cosine of theta, and the y coordinate is the same thing as the sine of theta. So let me write this down. Cosine of pi, oh sorry, we're at 2 pi over 3. Cosine of 2 pi over 3 is equal to cosine of 120 degrees, which is now going to be equal to what? Well, that's the x-coordinate here. And you just look at the x-coordinate right over here. It's 1/2 in the negative direction. So this right over here is negative 1/2. So this is negative 1/2. Now let's think about sine. Sine of 2 pi over 3 is equal to sine of 120 degrees. 120 degrees, which is going to be equal to what? Well, it's the y-coordinate of this right over here. And it's the same as the y-coordinate up here. We're square root of 3 over 2 in the positive direction. So that also equals square root of 3 over 2. Now let's tackle 4 pi over 3, or 240 degrees. So 240 degrees, you go halfway around, you're at 180 degrees. And then we're going to go another 60 degrees. So we're going to go another 60 degrees. And it's going to look something like, so we're going to go another 60 degrees. So it's going to look something like this. Look something like that, where we go 180, and then this angle right over here, often called the reference angle, this is going to be 60 degrees again between this angle and the x-axis right over here. So that's going to be another 60-degree angle. Let's figure out where it intersects the unit circle. You draw a triangle, and once again, we are left with a 30, 60, I know it's hard to read now, let me write this, 30, 60, 90 triangle. So based on that, we already know this. We've done this so many times. This length is 1. This length is square root of 3 over 2, and this length is 1/2. So based on that, we then get cosine of 4 pi over 3, which is the same thing as cosine of 240 degrees, which is going to be the x-coordinate of this point right over here, is going to be equal to what? Well, the x-coordinate, we see that we have gone 1/2 in the negative direction. So this is going to be negative 1/2. Now let's do the same thing with sine. Sine of 4 pi over 3, which is equal to sine of 240 degrees, is going to be equal to what? Well, the sine of the angle, of this entire angle going all the way 240 degrees, is going to be the y-coordinate of this point. So the y-coordinate of this point is the height of this side, but in the negative direction. We've gone below the x-axis. This is right over here. Let me be clear, it's negative square root of 3 over 2. So sine of 4 pi over 3 is negative square root of 3 over 2. Now let's do the last one, 5 pi over 3, 300 degrees. 300 degrees, going right over here, you get to 270, so we'll go another 30. We'll go another 30. This looks just like this. And another way you could think about it, and this is once again kind of the reference angle. So this is this going all the way around, that is 300 degrees. But if you look at the reference angle, if we go in another 60 degrees, we would have made a complete revolution. So this right over here, this angle right over here is 60 degrees. 60 degrees. And I think you get what's going on. You draw a right triangle. Draw a right triangle. This is 90 degrees. Another 30, 60, 90 right triangle. We know this is another radius of a unit circle, so it has a length 1. We know the short side, we've already figured it out, has length 1/2. The side opposite the 30-degree side. And the side opposite the 60-degree side is square root of 3 over 2. We've done this multiple times. So given that, what is cosine of 5 pi over 3, which is equal to cosine of 300 degrees? What is this going to be equal to? Well, it's the x-coordinate of this point, the x-coordinate of that point, which is 1/2 in the positive direction. So it's positive 1/2. Now, let's think about what sine of 5 pi over 3, which is the same thing as sine of 300 degrees. Sine of 300 degrees. What is this going to be equal to? Well, the sine of the angle is going to be the y-coordinate of this point right over. We went 300 degrees, or 5 pi over 3 radians. It's the y-coordinate of this point right over here. You look at its y-coordinate. We went square root of 3 over 2 down from the x-axis. It's negative square root of 3 over 2. And we are done.